so we can see the whole screen, and the agenda is blank. We're going to make it up as we go along. All right. I'm going to presume the people in the internet lands can hear me. Covering date time, date utils, and how Pandas, the data analysis library, covers dates. All right. First thing I'm going to do is I'm going to pull in some of the Pandas libraries. Do you guys need Wi-Fi? You need to be on the events SSID, and the email address will be PyHawaii@eolani.org, and the password will be PyHawaii. Yep. So the first thing we're doing, we're going to pull in some libraries and some modules and functions and things to help us begin our evaluation. We're not going to use these for a while, but we're just going to get it out of the way. We're going to start by importing Pandas. I use the alias PD, makes it easier to type later. From Pandas, we often use data frames or series, so I would tend to pull those in. And in the case that we decide to use some NumPy today, I would import NumPy as NP. All right. First thing I'm going to do to start looking at dates is I'm going to use the built-in library for Python, datetime. Several of the other things we're going to be using will require third-party libraries, but this one comes with Python. It's available all the time, makes it fast and easy. From the datetime library, I'm going to pull in two functions. One of them is called datetime. So I'm going to do from datetime import datetime. And from datetime, I'm going to import time delta, and we'll see how both of those get used as we go through. And using that datetime function, the very first thing we'll try is we'll create a date. And it's going to be a date object. So I say datetime parentheses, and I put a year. I then put a month. I put a day, and I close parentheses. And that's going to make a datetime object. I'm going to assign it a label. I'm going to call it date1. And I deliberately refer to this as a datetime object. It is not a string that looks like a date. It is not a sequence of just characters that you throw around and pretend are a functional living date. This thing actually has behaviors and attributes associated with it, and we're going to see a lot of them. And those behaviors and attributes give a great deal of power in terms of dealing with time. So let's see what we get back when we execute this bit of code. It tells us that we've produced a datetime object. We see 2016, 5, and 3 show up, but then we have these extra things, these zeros, and we'll figure out what those mean. Starting from the left, we have the year, and then month, and then day, and it starts to go downhill from there. And when I say downhill, let's take a look and see what this looks like. So I'm going to kind of ask IPython to tell me more details about the datetime module using the question mark. And it spits out this result. And it says when you have a date times, you start with year, month, and day. And notice those are essentially not optional. In the help syntax that Python typically uses, anything that's encapsulated in the function definition within these brackets is optional. So year, month, day are not optional, but if I want, I could include an hour. Beyond that, if I want to include more, I could include minutes and seconds and microseconds and time zone information. So in this case, when it spit out these zeros, it was essentially telling me, oh, by the way, you didn't provide me an hour. You did not provide me any minutes. All right. And of course, as always, if you have questions, you can ask as we go. Feel free to interrupt. All right, so we looked at that. I'm going to make 2 more dates. Very similar to what I did before, but this time I'm going to add a time in terms of hours. So it's going to be year 2016, 5th month, 3rd day, and 12 o'clock. I'll also create another date called date 3, and that one will be at 11 o'clock. And now I'm going to ask Python to take these 2 objects and essentially subtract one object from the other, or calculate a difference in time between one object and the other. So I take the date 2, subtract date 3 from it, and I'm going to get something back. And let's see what we get back. Actually, What do you think we might get back? If you had to guess, what might you expect to see? Okay, an idea might be a date time object and maybe a bunch of zeros for the year, et cetera, and just a 1 for the hour. That's an idea. Anything else? Or does that seem good? We're going to go with that? Is that the consensus? All right. We get back a thing called the datetime.time delta. And it gives me a 0 and a 3,600. What's 3,600? Where did that come from? Jeff knows. Number of seconds in an hour. All right. Well, let's find out why this comes up this way. So we're going to do the same thing. We're going to use the help functionality of IPython to show me the help for time delta. And it simply says that time deltas are the difference between two date time values, which is amazingly unhelpful. So we're going to use the verbose help option for time, IPython, which is 2 question marks, and we get back this thing. It will actually expose to you, in many cases, the source code behind the function you're asking about. So you're actually looking at some of the source code. This is the doc string at the beginning of the time delta class, and it tells you some of the details about this class. And a couple of things are that time deltas can be used, in adding and subtracting, multiplication by integers, etc. And here's the part that I really like. It tells you that when you get a time delta object back, you get days, you get seconds, and you get microseconds. Those are the 3 things that you can possibly get back. Now, that struck me as odd, and my first question was, well, I wonder why we get them back. Why don't we get back years, and why don't we get back months and stuff like that? And lucky for us, the guy who created this code chose to answer that why question right in his code. And he said, why? Because I felt like it, which I thought was awesome. All right, nothing like a snarky developer. All right. And he elaborates on that. He says, doing this efficiently and accurately in C is going to be really difficult. There's a lot of error proneness. You got these ubiquitous error overflow possibilities, and having the right number of bits to handle various things. So yeah, he did have a reason, right? Just really funny when he put it. Why? Because I felt like it. So, no, absolutely. Good point, Jeff. Yeah. Yeah. No, good point, Jeff. I appreciate that. Nope. Live with what you got. All right, let's see. Q. All right. When you've created a date time object or created a time delta object, as I mentioned, there's attributes, there's behaviors that are associated with these things, and you can pull those out. So we created a difference object. And we saw that it contained a 0 and it contained 3,600 seconds. And I can ask it specifically, show me the number of days in this difference object. I can also say, show me the number of seconds in the difference object. Can't type today. There we go. So you can actually pull out individual elements of a date time object or a time delta object. We're going to look back at the most recent date that we created, which was date 3. And they say, show me how many hours were associated with date 3. And I think it was 11. It was like the hour indicator we put was like 11 o'clock, sure enough. Or I can say, show me what day we had set when we created date 3. And it was the 3rd of May. Show me the year. There you go, 2016. So you have access within a date time object to grab any of the parts and pieces you want. What else can you do with one? Well, if you type in IPython the name of the object, and you hit a period, and you hit the tab, it'll show you all the things that you can do. We can do, a request for the minute or for the second. We can try and combine things. We can look at maximums, minimums, look at the month. We can do some conversions from a timestamp or from an ordinal value. We can look at time zones. We can evaluate them in terms of, international standards like ISO format. We can evaluate them in terms of like Greenwich Mean Time using UTC, etc. So there's a variety of things we can do. We are not going to go into these. I really want to get to the point where we start playing with pandas. So I'm going to leave diving more into this as an exercise for the student. All right. This is more kind of to whet your appetite that, wow, there's a lot of cool stuff we could do. All right. Date time objects have a number of ways that you can represent them. The fastest, easiest is just print the string representation of the date. A secondary method that will look extremely similar is to essentially print the ISO format of the date. So let's look at both of those. The first one will be the string representation, and the second will be the ISO representation. You'll see they're very similar. They both start out with year, month, day. The only real difference is one of them uses a T to separate the time from the date, and one of them uses a space. But what if you don't want to represent your time that way? What if you want to have it represented in some other way? You want slashes instead of hyphens, or you want to have some other separator besides a T or a space between the date and the time. Or maybe you don't want to show the seconds. Maybe that level of granularity is not important to you at this time. There are other ways to shape how you show time. And there are ways to shape how you read in time if someone gives you a date that's formatted in a way that you weren't expecting. To format times, and I never know the pronunciation of this. I call it stir F time. It's probably epically wrong. Don't know.
I call it stir time and stir time.
Yeah, so my good friend Jeff says it's stirf time and stirp time. These are links, well, the stir P time and stir F time, these guys are links to underlying C libraries. We'll talk more about that in a sec. We'll start with the formatting bit. You have a date time object, you want to get data out of it, and you want to display it to somebody in a format that you choose. In this case, I created a new date time object. I said, hey, it's the year 2009. It's the 9th month, 9th day, and I say date F. Give it a label of date F. That's what we're going to call it. And I say, all right, take date F, and now I want to apply a format to it. And I chose a format of %y hyphen %m hyphen %d. %y is shortcut formatting spec that tells it I want to use a 4-character year. The %m is a shortcut formatting specifier to say that I want to have my months in double digits with a leading 0 if it's a single-digit month. And the same thing for the days. It's going to have a leading 0. I'm not going to walk you through the full collection of formatting specifications. Again, kind of exercise for the student, just know they exist. If you want to see what they are, you can go to the Python docs, and under the date time modules portion of the Python documentation, they have a whole paragraph or whole table that lists the most commonly used formatting specs. I'll give you a word of warning. I have not confirmed this, but I've been told that because stirf time refers to an underlying C library, and those libraries may not be consistent across Linux, Unix, Windows, and Mac, there are a couple obscure formatting specs that may not be present in all of them. You can pretty reliably count on all the ones from the 1989 version of the C standard. They should all be present. But when you start getting into later versions of the C standard, 1 or 2 obscure ones show up, and they may not be universally available on all of your platforms. So if you have to go down that road of supporting multiple platforms, you may want to double check to make sure that all of your formatting specs are there. But anyway, let's see what this gives me, right? All the caveats out of the way. So I tell it to spit it out, give me 4-digit year, a 2-digit month, and a 2-digit day, and it hands it back to me just the way I asked. The hyphens that I typed in my formatting spec up there, they show up exactly as requested. If I had to put slashes, I would have got slashes back. Okay, let's see. The converse is true. If somebody gives you a format and you want to pull the digits out of it to represent the date, you can do that. Here I have a formatted string. The guy, for whatever reason, decided to separate day from month with a pipe and month from year with a pipe. So I've got to get rid of those. So I use stir p time or stirp time, and I tell it, hey, I've got this date time object. It looks like this, and I give it a spec. %m, %d, %y. And because the pipes are literal characters, I drop them in as literal characters. And let's see what we get back. Lord willing, it should give me the 8th month, 8th day, and 2008. And it does. And notice it bypasses hours and minutes, leaves those as 0 because it didn't read anything in that it could identify as being such. All right. All right. Again, whirlwind tour of this. That's the date time library kind of in a nutshell. We'll talk a little bit more about parts and pieces of it, but now we're going to shift to another library called dateutils. This is a third-party library. It does not come with Python directly. You have to go out and get it. If you use Anaconda to do data science, it comes pre-installed with Anaconda, so you're lucky there. It has an absolutely phenomenal parser, and you guys will see hopefully what I mean when I say phenomenal. Yep. Yeah. And it does it automagic with 0. I mean, you can tell it specific things to look for, but it does so many things automatically. So I'll give you a couple of examples. Some random guy gives me a date. It's 4-digit year, 2-digit month, 2-digit day. He throws hyphens in it. I will ask the dateutil parser to parse that for me. And if all goes well, it should break those into 3 different parts. I will then do the exact same thing, but with a different date. This time I'm going to hand it the word December. There's going to be a space. There'll be the 12th day. I'm going to throw a random comma in there to confuse it. I'll put a year in. I'm going to put a military-based time, 13 hours, 13 minutes, but I'm not going to have any sort of indicator that now we're talking about times. And then the last one, we'll get a little wonkier. I'm going to use the word the 23rd of January. So I'm going to throw in some of these, the 1st, the 2nd, the 3rd, the 5th, right? I'm going to throw in the word January again, a complete word. I've changed the order. It used to be December 12th. Now it's the 23rd of January. So I'm really mixing and matching the order of these things. Now I decide I randomly want to throw in seconds. And let's see if parser can handle all of these without being told anything. Notice when I call this, I don't tell it any of the details of how these are laid out. I just said, here's a string. Do whatever you can with it. And there you go. It pulls them all out. It can tell when there's minutes, when there's seconds. It puts all of the right things in the right places, months, days. With date time and dateutil, if you're looking at European months where they have like the day and the month kind of reversed from what we might do in the United States, you can identify that you're looking at a European style date. So it can handle that because, you know, the 10th day and the 10th month, you don't know. How are you? Welcome to the party. All right, excellent. You are live on YouTube at the moment, so don't say anything bad about your grandma. All right, so that's dateutil. I want more to let you know that it exists and that it is magic and that it's awesome, as opposed to walk you through an extensive use of it. We're going to move now into pandas, and we'll see what kind of magic pandas brings to the table, because pandas is pretty cool. As we go through this, I will remind you of a couple things that we've covered in the past 5 sessions or so on what pandas can do. And we'll eventually get to a point where we graph some things. So first off, again, I call in the pandas library using the alias I made for it, PD. I tell it I want to read in a CSV. The CSV is in a folder a little bit away from where my script is, so I kind of backtrack to the script or to the file. It simply shows 8 columns. There's a column with a name, a column with an email address, a column with a from IP and a to IP address, a date time, a latitude, a longitude, and then a payload size. I completely made up the data. It's all got like Avengers or DC comic heroes names and stuff in it. But by giving the argument of names equals and this list of things, I'm basically telling Pandas, as you read in each line of the CSV, every time you find something separated by a comma and you're looking at a new column, the first column is my name column, the second column is my email column, the third is my from IP. And it'll break up these columns very nicely for me, and I can refer to them by name later. I can say, oh, show me just the stuff in the names column.
What if you wanted to specify the variable type, right? Whether it's like numeric, character, can you also do that?
There are ways to tell Pandas what the data is so that it will read it. Because right now it's just going to read everything in as strings. But if you want it to be numeric, there are definitely ways to kind of manipulate all of those things and tell it, this is a 64-bit int, this is a 32-bit int, this is a float, etc. For those in Ethernet land, the question was, when you're reading in data, if you don't want it to be kind of automatically decided what it is, can you assign some sort of data type? And the answer is yes. The next parameter we give it is, I'm going to tell it, that date time column you just read in, I want you to use that as my index. And if you guys remember back, typically when we make a data frame out of Pandas, the index is always on the left, and it typically is automatically generated, and it will start with 0, 1, 2, 3. Here I'm telling it, I want my date to be my index. So I want to use dates potentially to find data in this spreadsheet. And then I tell Pandas, you know what, when you're looking at dates, if you see anything in here that seems to resemble a date, parse it as though it is a date. And then that's where the magic happens. So let's run that and see what we get. I'm going to tell it to display the data frame. All right, so let's go back and look. There's only 10 rows of data. We see on the left the data time is actually the index. We see that I have all the columns, name and email. For those who haven't seen it before, that little backward slash tells us that this is a row of data like you'd see in a spreadsheet, and it continues on a little further down in the page. So the rest of my columns are further down, the from IP, to IP, lat long, and then it continues down to payload. Notice for reference, it shows me the date time associated with each row in each of these. But let's just look at this, the first little bit. We see here in this data set that I've got 10 rows. The oldest date is February 6th, and it's sometime around close to 10 o'clock. The newest date is February 8th, and again, it's close to 10 o'clock. I use some randomized algorithm to kind of generate my dates and stuff. All right. So let's see what we can do with this. We're going to start off by pulling out just one of the columns, so when we display data, it doesn't all go spewing across the screen. I just want to look at the names. And the names were folks like Barry Allen and Dinah Lance and Arthur Curry and those folks. And for easy reference, I'm going to take that column out of the data frame, and I'm going to give it one name so I can refer to it. We'll call it names. Let's go look at it. As we pull out the single column, it keeps the indexes with it, so I can always use the same index for any given single column I pull out. All right, next. All right. I can ask Pandas to show me just the index. I say, I've got this data set called names. Give me just the index. And I'm going to save that as TS. That's short for time series. And it shows something that looks kind of like a list. Got all these dates. Notice at the bottom, it tells us that the data type is a date time 64. It's got an NS. This, unlike the Python date time library, will actually dive into dates to the nanosecond level, whereas the date time library in Python will only go to the microsecond level. So you can get very precise in terms of dates with Pandas. Notice on the left-hand side there, it is a date time index. Pandas is very particular about referring to things as indexes because it gives you a certain amount of power to deal with those. And in this case, it's not just an index. It actually is a date time index. So even though here on the screen it's showing these as strings, each of those is a date time object with a pandas twist. All right. And what does all that mean? Okay. It looked kind of like a list, and just like regular lists, you can ask for parts and pieces. You can do indexing or slicing. I can say, give me the 5th item out of that date time index. And Pandas starts counting at what? 0, right? So if I say, give me the item at index 5, that's actually the 6th thing in the row in the list. So it'd be, where do we go? 1, 2, 3, 4, 5, 6. So it should probably give me something that ends in 4726. All right, so let's run that. And sure enough, it pulled up the item 4726. Just like regular lists, you can slice. I can say, you know what, give me the item that starts in position 2, going all the way up to, but not including the item in position 6. And it gives me 4 of these things. If, like regular lists, you want to skip, say, give me everything from item 0 up to, but not including 8, and go skip every second item, you can do that. Go. And it pulls out 4 things. And if we were to do the analysis, we'd find that it bypasses several of the items, skips every other item. So very handy. You can get to the dates that you really want. But wait, there's more. What if I don't know that an item is the 27th item in my index, but I know the date? I know that something occurred on February 6th at 21:47 and 2 seconds, and I want to see the data associated with that event. I can go into my names column and say, find me whatever happened at this date time, and it'll pull it out and say, yes, Arthur Curry's activity occurred at that time. And that's pretty handy. What if, though, I am interested in finding something that happened on this date, but I don't really care about the time? You can simply ask for the date, and it will ignore the times, and it will pull back all the stuff that happens on the date. And I don't have to do any magic. I don't have to go in and reformat the index, and I don't have to separate out the dates and times. I just say, you know what? Anything that contains this part, find it for me. And it pulls up, out of those 10 items, all 8 that occurred on February 6th. Okay. Say, well, all right. There's a couple more things that'll come up here in a little bit. All right. For our next trick, I'm going to read in a little bit longer list. It's the exact same format, same kind of data, but instead of 10 rows, it's 1,000. I do all the same things. I name my columns. I tell it that date time should be used as an index, and it should parse dates. Again, in order to kind of keep the screen clean, I'm going to say only look at the names for now and store that away and give me a way to reference it, and I'll call it names long. So we do that. Names long. Let's go look at this thing. Notice it starts up at the top. Same situation. We have the names. Something to note. There's supposed to be 1,000 names here. It cuts out the ones in the middle. It only shows me the ones at the beginning and the ones at the end. It tells me this by showing me the ellipses. That is completely customizable in IPython. I can tell it to show me all records. I can tell it to show me 100 records, 20 records, whatever. But this is the default. And we notice that the oldest time is 2015, sometimes September 4th. And the newest item is, again, February 8th. All right. So let's see what we can get with this. I showed you how we can index using that first half of the date time string. You can make this as simple and complicated as you want. I can say, well, you know what? I just want to see all the stuff that happened in the year 215. And again, with no parsing, no magic that I have to do on my behalf, I just say, look in the index and find anything that's 2015. And I should get about 750 records. Sure enough, as I start to look at this, the stuff at the bottom, and I scroll all the way up to the top, it's filtered out everything that happened in 2016. I'm only seeing 2015 data. If I want to figure out exactly how many records there were, I can ask it, say, oh yeah, how long is this data set you just returned? It's 742 records. All right. But what if I want to be persnickety and I want to find stuff that happened in September 2015? And remember, the date times are represented in numerical values, but persnickety me, I want to type the word September in. I can do that. I say, help me find anything and everything that happened just in the month of September. And it does that. I don't have to do anything. And lastly,
So can I ask a quick question on that?
sure,
I don't know if it's like also interactive Q&A, or if you get to a certain amount of.
you are allowed to ask questions. I actually encourage it because, man, I always feel like, gee, nobody's listening. So ask away.
I was wondering if you can do the reverse, right? So if your index is not in numeric format, right? It's the September whatever day and then 2015, and you wanted to, only extrapolate 2015-09, right? Could you do the exact opposite? Can it switch over?
So
library?
So the question here is, if my dates, instead of being written in numeric format, were written in something like October 2015, could I potentially feed it numbers and have it find the month of October? I honestly don't know the answer to that question. It depends on the sophistication of the Pandas library. I've never tried it. It would be something fun to try, but we're not going to do it here at this particular second.
So this is actually, I work a lot with R.
Yeah.
It's a limitation with R, and the packages that are built in too, is that you can't do the reverse. It's easy to
Go one direction, but maybe not the other. I've never tried it. It would certainly be interesting to test. All right. So in this case, I'm going to ask it for the month of October. I'm going to throw that random comma in there because, again, I'm snarky. And we'll see whether or not it can do this. And sure enough, it does. It gives me just the things that happened on the 31st of October. All right. And apparently, Wonder Woman was quite active on that day. She had 3 entries in my logs. Sweet. All right. We talked about slicing and indexing earlier, and we said, you can index by an integer, or we can index by a particular date of sorts. You can also do slicing. I can say, go from October 29th up to October 31st, and use kind of the standard slice syntax of putting a colon between your starting point and your ending point. And when I run this, it'll give me about 28 some odd results. And they all are between the 29th and the 31st. Slightly different from what you might normally expect with Panda or with Python. Python always goes up to, but doesn't include the last part of your slice. In this case, it does include the last date. So be aware of that subtle difference. Trying to avoid some off by 1 errors. All right. This next part, I'm going to manually do a little bit of slicing and dicing on the date just because I want to. See, I learned something from Python developers. I'm doing things just because I want to. So I'm going to create a small function called date split. I hand it a date. It'll be a string. And I use very simple string manipulations to look at the object. I then split the object. Any place there is a T, that produces a list with 2 separate components. And then I tell it, just give me the first item, the 0th item. But here's the part that I really want to do this, because that was a trivial exercise creating that function. But when you have a component in a Pandas data frame that you want to convert, manipulate, or whatever, as you are reading the data in, they have this converters parameter where you can say, look at the date time column and apply the date split function that I've defined to that column. And because this is a dictionary, if I have multiple functions that I want to apply to different columns, I can list each column and give a different function. Here I only had a single column, I had a single function, but if I wanted to apply a function to the date time column, and I wanted to apply a function to the IP columns and a function to the email column, I can do as much sophisticated manipulation of the data as I'm reading it in that I want. So again, my function was fairly trivial, but it was mostly to expose you to the fact that as you read in the data, you can convert it on the fly before you kind of fully formulate your data frame. So we're going to produce a new data frame called DF2, and it's going to be long because there's 1,000 records. We see there's 1,000 rows, there's 7 columns, yada, yada, yada. All right. So from here, and I've got a whole nother conversation that talks about grouping by particular parameters. So this is just a gloss over. I'm going to wave my hands at this. Just trust me that it works right. I'm going to take my data frame. I'm going to look at the name column, and I'm going to group all of the rows by the individual names. So whenever Wonder Woman shows up, any activities associated with Wonder Woman get put into a single group. Any activities that are associated with, you know, Barbara Gordon or John Jones or Clark Kent, they all get grouped together into individual groups. And once I finish the grouping, I'm going to say, just tell me how big each of these groups are and give me some indication of that. And sorry. All right. I screwed up. We're going to rewind. I'm grouping my data frame. I'm only interested in the name column, but I'm grouping by the index level 0. Sorry. So that lumped everything that happened on the 4th of September into a single group, and I have 2 records that were associated with that. We don't know whose names are associated with them. I had 3 records that showed up on the 5th of September, 6 that showed up on the 6th of September, etc. Sorry. You get confused sometimes. I'm going to blame it on Jeff. Jeff's like, what? Why me? Good enough. All right. There was one other thing I wanted to show you about the grouping. I want to take a quick look at the first record from each group. And again, I got a whole nother class where we talk about grouping. So we're not going to dive too deep, but I can look at each group. I can look at that one group that started out on September 4th and say, show me the first record out of that. And that can give you kind of an overview of what your data is or what it looks like, etc. And there's a whole slew of ways to process each of the groups. All right. So that's handling dates with pandas when you kind of already know the dates and you've got things, and the dates are typically going to be irregular. Maybe you're collecting data from some sort of a sensor, or you've got a logs, or it's manually generated dates, etc. But sometimes you want to evaluate those dates in different ways. You might want to downsample or upsample. You might want to have more date values or less date values. Say you get data that comes in every second, but you don't want to put every second's worth of data on a chart. You want to essentially show what's the average values every hour and put it on a nice graph. Or what was the maximum value that showed up every hour? I might have 3,600 data points in a single hour, but I don't want to show all of them. So you can do resampling. And resampling can be done to upsample or downsample. In this case, I've got my data set DF2 long, and I want to look at it every 4 hours. Group it into 4-hour intervals. If you guys recall, I had stuff that showed up every day, and they were random times. So when I resample this, we'll get some, hopefully some interesting things. All right. Let's see, dfres. When you do resampling, there are ways to change how it handles it. The defaults are it will try and resample in the frequency that you've provided. I told it 4H, which stood for every 4 hours. So you notice my timestamps are every 4 hours instead of the randomness that we had. And by default, it tries to resample and provide you with a mean. So there's no way to get a mean of names. There's no way to get a mean of IP addresses. But the lats and longs were, just float values. My payload size was an integer value. So tried to calculate a mean for just those 3 columns. And we'll see other ways that you can handle this. But it tries to break up your data. In cases where it cannot make a clean definition of data associated with a resampled frequency, it will provide you with not a number. Okay. There are ways to override that. You can tell it in the resample definition that when there is a not a number response that it would normally produce, to pad it or fill it with something different. All right, so let's take a look at this real quick. df long resample. df2 long.resample. I'm going to use the question mark to call up the help function for this, and we'll see a few items. Starting at the top, it's the rule that you provided. In my case, I said 4H, which meant 4 hours. You can tell it, I want to resample by either downsampling and use the method of mean calculation. There's other ones that you can use, and we'll look at some of those in a little bit. If things need to be padded or filled, you can tell it what to pad or fill with. If you have limits or offsets, and each of those items are defined down here. You can tell it to resample and shift to the right or shift to the left. So if you have numbers that are above your target, you can have everything shift down. If you have numbers that are below a target, you can have everything shift up. Right. But again, there's a lot of complexity here, and I'm going to leave a lot of this kind of the exercise to the student, so you guys can kind of figure out what you can do with it. This is more to let you know what the art of the possible is. All right. Let's see what else we had before we go on. All right. In this case, I'm not going to run this, but instead of resampling by every 4 hours, instead of resampling by 4H, I can say resample by every 2 days. And actually, what the heck? We'll run that. Command C. Let's see what we get. And df res 2d. And notice now all my dates, skip dates. It's the 4th, the 6th, the 8th, so every 2 days. Again, the default was to kind of calculate a mean of all of my latitude values during that 2-day span. All right, so let's look at some of the other things. All of your frequencies are typically defined as a base frequency and some sort of a multiplier. So M, capital M, sorry, means month. And you can say every 2 months, every 3 months, every 8 months. Small h stands for hours, and you can say every 2 hours. And you can mix and match some of these things. I can actually put 2h 30 min, and it'll actually resample by every 2 hours and 30 minutes. You can do daily. You can sample by business daily, where if you're only looking for information that occurred during the business week, Monday through Friday, it's smart enough to pick those out. It'll essentially look at a calendar in the background for you and say, this occurred on a Monday, this occurred on a Saturday, and resample in that way. It also takes into account a lot of kind of the business logic. You know, some businesses live and die by the end of the business month. What day of the month happened to be the last business day? So you have the capability of diving into business month and calendar month and those types of things.
Does the calendar pull in holidays as well? So like for instance, if this month fell on holiday, would it discount it?
Do not know the answer to that question. I've never had to deal with it. Not sure. Again, it's a good question. I don't know. So the question over here was, all right, so you say this thing's really good. Just how good is this thing? Does this actually take into account holidays, or does it suck that way? And I'm like, I don't know. Is that good enough? All right. You can do a couple things, like you can say, hey, I want to look at data on a weekly basis, but on Mondays of the week. So you can do something like W-Monday. You can articulate a particular week of the month. Say, I'm really interested in stuff that happens on a week of the month, week 1. And I want to look at the first week of the month, but Tuesday. You can look at things by quarter. and you can identify, I want to look at the quarter and I wanted to start at January. So quarter 1 would be January, quarter 2 would be April, etc. So a great deal of flexibility. You have to dive into kind of the help functionality to get all the details on how you can break out these frequencies. But it's there, and it's awesome. All right. So next, time zones. So time zones are like the bane of most time people's existence because they're horrible. You have time zones that have daylight saving. You have time zones that don't. You have time zones that are, kind of off by 30 minutes. You have time zones that are not off by 30 minutes. And time zones change. The last I read, I think about once a year, someone in their right minds someplace on the planet decides to change their time zone for their city, their county, their country, their state, etc. So time zones are and they change their daylight savings time rules. Yes, everybody and their brother has to come up with a better way to do daylight saving. So handling all that is a brutal disaster if you try to do it by yourself. Some of these things are built into the Python and Pandas libraries. So we're going to look a little bit at time zones to see if there's ways to kind of help you out with some of these things. All right. First off, I'm going to look at a data frame. It's one that we made earlier. It has 1,000 records in it. I just really care about the name column, and I'm going to slice the name column and say, yeah, look at the name column, but I really only want to see records from 0 up to 750. There's no real reason to do this, just to remind you that it's that easy to slice and dice some data. And the rules for slicing in Pandas are different than R on certain levels, and that's really annoying. I have homework in R, and I have work in Pandas, and I struggle with this all the time. Like, but regardless, it is what it is.
Which one do you prefer?
Pandas. All right. Hadley Wickham is rolling in his... Anyway, so I'm going to ask for the first 750 rows, and I'm going to save that as times. And then I'm going to ask to print out, give me just the index and tell me the time zone that is associated with this index. And if you guys remember, there was absolutely nothing in my data set that even remotely hinted at time zones. So it's going to tell me that, Chalmer, dude, you gave me no time zone. There is none. So let's fix that. I can tell it that with my times data set, I want to localize it and use the US Eastern time zone. And there's an immense list of time zones, and they all have particular spellings and stuff like this. And you can look that up in the Python libraries. In this case, I chose US Eastern, and I'm going to give it a new label so I can refer to it, and I'm going to call it times_EST. And times_EST.index.tz, and it'll say, hey, you're now using a time zone of US Eastern. All right. If I have data that is in a particular time zone, but I don't like that time zone, it's a mainlander time zone, and I want something that's like more local, right? I can actually use the convert function that's in Pandas to convert it from mainlander to Hawaiian. And then we do times, can't type today, times_HT index.tz. And sure enough, it converted it for us, and it shifted everything over. And if we were to look at these two dates and times, let's see, EST, a couple things to note. It has changed my timestamp for me. It now gives some sort of an indication of how far away from GMT we are. All right. And if we look at Hawaii, it shows that, we're 10 hours away from Greenwich Mean Time. All right. And that's how it calibrates everything in terms of time zones. It measures everything against universal time. All right. All right. Next. So predominantly looking at irregular timestamp data. We did look at how we convert that to periods, but what if we really want regularly spaced data? We want to create some level of periodicity. That's built into Pandas as well. I can say, I want to look at the year 2015, and I want it broken up into periods with a frequency of weekly, looking at Monday of each week. And again, the frequency uses the exact same specification codes as the other product we were looking at a couple minutes ago. And we say, all right, so show me period. And it'll tell me, hey, we're going to go from the end of December 2014 all the way up to some time frame in 2015. All right. Because weeks tend to break off at random intervals at the beginning and ending of years, sometimes your dates when you're looking at periods will cross over the year line. Just be aware of that. If you have a particular range you're looking for, you want to say, I want to start at this date and go to this date, something in 2010 all the way up to 2015. And then we'll look at quarterly. You can do that. So, and the period range function acts a lot like the regular range function. You can give it a start, you can give it a stop, and you give it a step, if you will, a frequency. And you notice it gives me the year 2010 quarter 4, 2011 quarter 1, and it cruises all the way up. All right. And notice that down here at the bottom, it indicates both the frequency and what is the starting month of my quarter. Because my starting date happened to be in December, it made a default decision that he wants his quarters to start in December. And you can define that if you need to. All right. If you have period and you want to break it up in a new period, you can convert that and you can say period.asFrequency. And we can say, I think period before was week starting on Monday. So we're going to change it and we'll get a frequency of weekly. And we want the first date of each week to be the start. This how parameter says you can have start, I think end, a couple other parameters. And you can basically define when should this period begin. Do I want my period to start at the beginning date of that window or at the ending date of that window? So again, purpose is to give you a lot of flexibility. All right. And in most cases, Python, I think, starts counting a week window on Sunday. You can tell it to start on Monday if you need to. But when I said, hey, look at each week and begin with the start of the week, it picked Sunday. Okay. Next. If you have a sequence of periods, like we had in that range, it will convert all of them. Before it was quarterly. Now I want to convert it to daily. Let's see what we get back. Looks at each quarter starting on the first day of the quarter, October 1st, January 1st, April 1st. All right. I have a data frame and I want to convert it into a periodicity. We can do that. It took off all of the days and it converted to a periodicity of months with a capital M. If I remember right, it just simply strips off all the dates. All the data remains intact. And we're getting close to the end. If you have periods and you want to convert things back into timestamps, you can do that. You have a loss of data, though. We stripped out the dates, and now we tell it to convert it back. It didn't have a date to point to, so in this case, it gives a default date of the first of each month. Okay, so you got to be careful about kind of repopulating data with by doing a conversion to something like a timestamp or a date stamp. Let's see. Here, I'm going to take a data frame. It's got 1,000 records. I'm going to ask it for 2 columns out of the data frame, the latitude and the longitude columns. I'm going to ask it to do a nice resample for me. And I'm going to tell it to resample on a quarterly basis. And instead of looking for the mean like I did before, I said just find the maximum value. Right there. And I'll be honest, it's late in the day and I can't remember what the period means. Hopefully when it comes up, I'll remember. But your how parameter can be any of these 7 following things. You can say, show me the mean, the median. You can show me the count of items that were in there, the mode, minimum or maximum, the standard deviation of the variance, etc. So let's see what we get. All right. It broke it up into quarters. The data set was only 1,000 records long, so it was only about 3 quarters worth of data in it. And it gave me the maximum value out of each date, and they all showed up to be roughly the same. The randomizer that I used went up to about 50. All right. So let's try and remind ourselves what the resample period is about. Can't remember. So we're going to ask a question there. And the period. And I do like this one, the resample one, because they have some very nice examples, and they'll walk through multiple examples of how to create periods. So this first example talks about creating a series with 9 one-minute timestamps, and then we're going to do some downsampling on it. I'm going to downsample it into 3-minute bins, and we want to sum all the values with those timestamps. And they show you some examples of various types of downsampling, using various labels to kind of shift all the time to the right and to the left. So if you notice up here, near the top of the screen, by default, it starts my time sample from 0 up to 3, from 3 up to 6. If I tell it to shift to the right, in that 3-minute window, instead of starting at 0, it starts it at 3, and then goes from 3 to 6, 6 to 9. So you can shift where in the period you want to gather or you want to assign data. Let's see. I'm not seeing the bit about the period yet. For the fill method, if you want to pad it with data instead of having not a number show up, it will take essentially the first value that it finds for that period, in this case is 0, and instead of having a not a number because it didn't know anything, it will replace not a number with a 0. When it finds a 1, instead of having a not a number, it'll replace it with a 1, and it'll use that fill method. If you want to go the reverse direction, you say, all right, I want to do a backwards fill. There was a not a number here. Instead of filling it with a 0, with like you do forward filling, I'll just go backwards and find the 1 and fill the not a number with a 1. We talked about how you can use min max for how. Standard deviation. If you have your own function to do some sort of an assessment, you can actually funnel in your own function to say, look at this and calibrate something for me or calculate something for me. I'm kind of annoyed that I didn't see period in here. I will have to look it up on the interwebs. All right. And so we've looked at some data. We've kind of sliced and diced and parsed it. Let's put it on a graph. Let's make a picture. From here, I'm going to import matplotlib, and I'm going to import their pyplot function, and I'm going to give it an alias of plt. I'm going to run the interactive function on plt to say, as I make my graph, I want to see the changes in real time so I can see how my graph is developing. We're going to start off by saying, okay, take my data frame with 1,000 records, look at just the lat long columns, and take only the first 750 records. And save that off as df1000. I'm going to create a subplot. That subplot will have 2 rows, 1 column. That's what the 2 is for, and that's what the 1 is for. This last indicator tells me which of the plots I want to be the active one. So I'm going to be looking at the first plot, and I'm going to play with it and decorate it with details. And then in a few seconds, I'm going to tell it, hey, Out of those 2 rows, 1 column, I now want to look at the second plot, and I'm going to change some details about it. So what kind of details do I want to put? I want to look at just the latitude, and I want to plot it to my graph. And there's some default functionality in the plot that makes a basic point graph, kind of like scatter plot. And I'm going to tell it that the style of my points, I want them to be black, which is their term. They define that as K. And I want them to be circles. When I do the second graph, I'm going to plot the longitudes. And I want it to be blue. And I want it to be little tiny triangles. So let's see what we get. There we go. Notice that latitudes go from 45 degrees to 50 degrees. Longitudes go from 7 to 13. And these are the lats and longs on each individual day according to my graph. And again, this is fairly randomized data, but we can see it's not really random. Amen to Python's pseudo-random number generator. All right. Next. From here, I want to grab a smaller set of data. I'm only going to take 40 records. I'm going to do some resampling on this data. I'm going to resample using the mean. I can't remember what the B was for. Dang it. We're going to drop all that into some sort of a bar chart. And when I was putting this thing together, I will forewarn you, I kind of screwed up. I meant to have this plot to a brand new graph, but I didn't. So we're going to have this blue dots are all going to shift down some crazy place, and they're going to be all skewed. And then we're going to have some really bizarre looking bar charts that show up on the right-hand side. The bar charts will use my timestamp index. And with matplotlib, you can get very specific about what you put on the chart. Or you can use the defaults like we did a few seconds ago. But here I'm going to tell it I want to plot the timestamps versus the latitudes. I want to use a color of red. For my second bar, I want to do the same thing, but it'll be longitudes. And I want the latitude values to be on the bottom of this stacked bar chart. And I want the color to be blue. And it's going to be a really bizarre looking graph. I apologize ahead of time. And so, again, it mushed all of the data points to one place. You can't see any of the difference between the bars. I'll have to work on that. But nonetheless, you can make charts, and it's fun. And matplotlib can inherently understand what your index is showing when it talks about dates and such. So I thought that was useful. And that's all I got in terms of that. But I do have a gaming website that I'm playing with, and I'll show that to you guys after we do questions. So, questions?
One of the libraries embedded in the library as well, or is it a separate library? And are there other visualization?
Sure. So last time we met, the entire conversation was about visualization libraries. It's all available on YouTube if you want to watch it. But so the question was, so matplotlib lets you do graphs and visualizations. That sounds lame. Isn't there anything else? And the answer is yes. So matplotlib is kind of tried and true and trusted. There are some folks who will make the claim that matplotlib is feeling a little long in the tooth and getting kind of old and might be supplanted by some other libraries. Some of those libraries include Bokeh, companies. I think Plotly has got a library out there that I think uses DS or D3 to do some very cool interactive visualizations, as does Bokeh. Bokeh is really good at doing interactive visualizations as opposed to static pictures. There's a library called Seaborn. Its whole purpose in life is to make using matplotlib easier. It has predefined palettes of colors, so you don't have to pick them. And they used like graphic designers to help come up with good palettes that blend well. So you don't have like crazy yellow, crazy red, and like, you know, hard to see and hard to visualize things. So Seaborn is really good, and it simplifies a lot of the producing of a graph. Matplotlib, Seaborn, Bokeh, they all have galleries that you can look up online where people have produced really slick looking graphs. I think the matplotlib gallery's got like 150 some odd different types of graphs of every sort. And the awesome thing about each of these libraries is you click on the picture you like, and it gives you the Python code that made that picture. So it makes it really easy to implement that style of graph in your code. So yes, there are other libraries, and some of them are pretty slick. I've been playing with Bokeh, but I haven't made enough progress on it to actually sit down and demo it for anybody. Any other questions?
There's a Python podcast, Talk Python to Me, and the author of Bokeh was on there, and they just had a data science episode too. I highly recommend that.
Sweet. Talk Python to me. So
What's the name of it?
for those in Ethernet land, I'm going to tell you about a competitor. There's someone else out there who apparently talks about Python to people, and apparently this guy has a podcast. It's called Talk Ruby to Me. So go look that up. And no, it's Talk Python to Me. And apparently he has done a data science podcast and a podcast on visualizations, particularly focused on Bokeh. Apparently they had the author or one of the authors of Bokeh on. So go look that up. Should be a lot of fun, cool stuff there. All right. And if you guys are interested, I'll show you Code and Game. This is my new favorite thing to do, besides play like with my daughter and stuff. The spelling of this is a little quirky. It is codingame.com. Code and Game. So they merged coding and game, and they lost a G somewhere in there. Game. Run by a French company. And the principle here is that they give you opportunities to compete either essentially kind of against yourself or against other folks. And they allow you to compete on various levels. The easiest level, or probably the most generic level, is the puzzle level. You go in, they provide you with a puzzle, you try and solve the puzzle, and you get points, and you rise up on the leaderboard. So they have a fairly simple tutorial that gets you onboarded, and you get 30 points if you successfully complete it, and you get some accomplishments. So those folks who are kind of driven by points and badges and awards and things, you know, this is a real good motivator to keep going, keep plugging along. You can see that 206,000 people have attempted the onboarding tutorial and successfully completed it. As the puzzles start to scroll down the screen, you'll see fewer and fewer people have done them. Only 6,000 people have finished Indiana level 1. They tend to have a lot of things that are kind of focused on popular culture. Let me see if I can show you one of these examples. All right. So they have some sort of a screen, and it's your playing field, and you have to solve a puzzle. They define the goal, and it says, your program must allow this character called Thor to reach the light of power. The rules for this particular game are this. Thor will move on a map. This map is 40 spaces wide. It's 18 spaces high. The coordinates start at the top left. They're X and Y. They will give you a variable to show you the X and Y coordinates of the light. They will give you an initial variable for Thor to show you his X and Y coordinates. And you have to print out either an N or an NE, an S, an SW, to tell it which direction to move Thor, north, south, southeast, southwest, etc. And if you can get Thor to the light of power, you win. And then they give you these test conditions over on the right-hand side. The first test condition is always the easiest. Can you make Thor simply move in a straight line? Can you move him up? Can you move him in an easy angle? Can you move him in what they call an optimal angle? And they will provide, in some cases, some kind of bounding parameters. Like you have unlimited number of turns to get Thor there, or you have X number of turns to get Thor there. And if your algorithm doesn't move Thor optimally, you may not get him to the light of power in the right amount of time. Let me see if I can bump up my size of my text here. Oh, that's horrible. Good Lord. All right. By default, they always import sys and math. If you want to print kind of debugging information, you have to print it out to file equals standard error, and it'll show up, and you can see debugging stuff. They give you an input, and this bit of code was already written for you, and it says, hey, we'll provide you an input. It'll be a sequence of integers, and they break it out right off the bat for you as light, x, light, y, initialize Thor x and initialize Thor y. And then they set up this kind of while true loop to start going through Thor's current position versus the light, his new position versus the light. And they will start off by telling you how many remaining turns you have. Again, a lot of this is kind of already built in boilerplate. And then I did some random, probably highly unoptimal testing. If the light position is different than Thor's position, I want to add a single step to Thor's initial position, and I want to move him in a particular direction, and I start to kind of change his position. So every time it cycles through, it will update where he is and all these things. And as you get some sort of a code that you think works, you can say, play the test case. And it will try and move Thor randomly across the screen. And unfortunately, because of having to blow the screen up, you don't see everything. But you can actually tell it to kind of zoom forward. Took Thor 27 steps to get there. You can have it go faster or slower if you need to. When he reaches the lighted power, it gives you this little thing. I can run the next test case. All right, so he's got to move straight up in a straight line. Let's play one where they move him at a slight angle, and he's got to kind of drift down. He's got to go find the light. It's hard to see maybe in the screen, but there's this boundary. You have to make sure it doesn't go outside the boundary, otherwise you lose. When you feel like you've gotten all the test cases right, and you can test them individually, but when you feel like you're done, if you want to just play them all, kind of final check, you can do that. And when you're fully committed, you hit submit. And if your code works, you win and you get points, which is cool. All right, so let's go back. So that is kind of the puzzle part. They have regular contests that show up. The current contest started about 4 days ago. It's going to go for, I think, another 3 days. They have this almost Tetris-like environment where you've got 2 screens, and they will provide you a series of 8 blocks. And the blocks are random colors, and they will start to fall down on the screen. And you actually have to build an artificial intelligence to try and place those blocks optimally, just like in Tetris, so that you can clear out blocks. And as you clear out blocks, you will end up punishing your opponent who's competing with you. And he will get these skull-colored blocks that will block him from being able to put together sequences or linkages of blocks. And occasionally, if he gets it right, you'll get these things on there. So your AI has to determine, do I have the skull blocks in my side of the screen? Where are my colors? Which colors have now disappeared? Which colors are coming up? And they'll tell you the next 8 sequence. So that's kind of cool. And you have basically a week to try and create AI that works. And when you have AI that you think works, you run it, and they'll assign you a random competitor, and you guys compete head-to-head with your AI. And if you win, you kind of move up in the ranks. If you lose, well, you feel bad about yourself. But the thing I like the most, and this is the one that's addicting to me, is this thing called Clash of Code. I'm going to shrink the screen down because this is annoying me. Hopefully you'll get kind of the gist. All right. So they have kind of recent clashes that have happened off on the right-hand side. Sala 4 and Fulgrim fought. You can go and kind of look at their scores. The Flash is, it says it's a 5-minute competition. They actually allow you up to 10 minutes to run. When you ask for a Flash competition, they will dump you into a room, and they give about 5 minutes to wait until somebody shows up. Once the room starts to fill up with players, they'll eventually kind of run down to 0, and they will dump you into a game. You have no idea what the game is going to be, and the game could fall into any of 3 basic categories. The first category is, much like those puzzles I showed you, here's a problem, solve it. you have to be able to beat all of the tests that we give you, and you have to do it faster than anybody else in the room. So you're competing up against 7 other people, and they could be using whatever language they want, Ruby, C++, whatever, assembly. And whoever finishes the most tasks in the least amount of time wins. You don't have to finish every task if you don't want to, and at the very end, they're like, all right, you ran out of time. You can just submit if you want. So that's the first class of puzzle. The second class of puzzle is solve the problem. It's not necessarily as important to be the fastest, but you have to solve it in the least amount of code. So they'll count how many characters you use. So it's kind of like code golf, and that's kind of fun. And again, these are randomly picked. You have no idea if you're going into a code golf situation or a fastest time situation. And then the last one, which I hate, is they don't tell you what the puzzle is. They just tell you, this is an input we give you, and this is the output we expect. And they'll give you like 8 of these. And they go, you figure out what the puzzle is. You figure out why we want, or what we want you to do to go from A to B. And that always kills me. I fought against some guys last night, and I could not figure out the puzzle, so I got 0 points. When you're done, I'm going to leave this clash. Let me go. Let's see, you can go to leaderboard. And right now, I'm out of the 20,000 people that actively compete in these Coda clashes. I'm somewhere around number 220. I've been in 38 of these things. This is my score. I have half the score of the best guy. But you can kind of look at, out of all the coders that I follow, how am I doing about them? Who are the people who are closest to me? Who do I have to beat, etc. So anyway, I'm a big fan of it. Been having a lot of fun. So we see here in this case, Salda and Fulgrim, they were competing. Salda finished all of the tests. He got 100%. It took him 9 some odd minutes to do it. And he did it in only 88 characters, whatever that puzzle was. And you can go back and try and replay things if you'd like. So anyway. Huh?
Why did it have not applicable language for the other?
He may not have showed up. Or he may not have defined his language. If you looked, he got 0 points. His character count was 0. So he probably didn't type anything in, and he might not have said his language of choice. You are allowed to program in any language that they support. Most people will choose a language that they like the best, and they will kind of flag that on their profile, but you don't have to. But if you wanted to compete in C now and Python tomorrow, that's all available to you. You can do that. So, but anyway, I've lost a lot of sleep this past week playing this silly game. And it's amazing at 1 o'clock in the morning, random dudes are like, oh crap, that guy slaughtered me last game. Don't show up in my lobby again. Some other places that I go for puzzles, Check.io. Let me write that down. So coding game. Check.io, checkio.org, I think. Project Euler for the math nerds in the room. I think it's projecteuler.org. There's the Python challenge, but I'm not a huge fan of this. I think it's .org. And there's Reddit Daily Programmer. Daily Programmer. Those are all places I go. So. Around midnight Eastern Standard Time, since this is a French company and a lot of the folks are around midnight, the number of people who show up in the rooms is a lot slower. This morning before I went into work, the rooms would fill up nearly instantly, which is really cool. And you can potentially join as many clashes as you want at the same time. It's okay. So that's that. For those in Ethernet land, glad you joined us. Have a great day, and I'll talk to you guys later. So that's that. Man, I wish these guys would come up because I wanted to show you guys the thing. It's pretty slick. They dump you in the room. You have 10 minutes. If you solve it, you do. If you don't, you don't. Whereas with like some of the Project Euler problems or whatever, you know, being the anal retentive guy that I am, I want to finish it. And if it's really hard, you know, it could take a day, a week, whatever, to try and figure out, holy crap, how do you solve this thing? With this, 10 minutes, it's over, done. Yeah, I couldn't solve it, oh well. So it's less abusive for me mentally. And let me kill the Hangout here. Where did I put the Hangout? Oh, stop the broadcast.